the radius of a sphere is x meters, surface area is given by the formula 4 pi times the square of the radius, and volume is given by the formula 4/3 pi times the cube of the radius, what happens to the surface area S and to the volume V of the sphere when you A. quadruple the radius, B. multiply the radius by n, C. divide the radius by 3, and D. divide the radius by n? Well, let's first of all complete the first row of the table using the given information. We're given that the radius of the sphere is x meters. We're given that the surface area is S, but we can also calculate the surface area using the given formula. The surface area is 4 pi times the square of the radius. In this case, the radius is x, so S is equal to 4 pi x squared. We're given that the volume is V, but we can calculate the volume using the volume formula 4/3 pi times the cube of the radius. In this case, the radius is x, so we'll get 4/3 pi x cubed. For part A, we want to determine what happens to the surface area S and to the volume V when we quadruple the radius. Well, quadruple means to multiply by 4. So after we quadruple the radius will be 4x. To determine the corresponding surface area, we can substitute 4x for the radius in the surface area formula. That will give us 4 pi times the square of 4x. Our goal is to rewrite this expression in terms of S. So let's compare the two expressions. Both have a factor of 4. Both have a factor of pi. Both of them have a factor of x squared. The only difference is this 4 that's inside the parentheses, but that 4 is being squared, and 4 squared is 16. So we rewrite the expression as 4 squared, which is 16, multiplied by the remaining factors, 4 times pi times the square of x, 4 pi x squared. But 4 pi x squared is just s, so we can substitute s for 4 pi x squared, and that gives us 16s. So what happens to the surface area when the radius is quadrupled? Well, we see that the surface area is multiplied by 16. To determine what happens to the volume, we substitute 4x for r in the volume formula. So we'll have 4/3 times pi times the cube of 4x. We now compare this expression with the expression that we have for v. Both have a factor of 4/3, both have a factor of pi, both have a factor of x cubed. The only difference is this 4, which is raised to the third power, and 4 to the third power is 64. So we rewrite the expression as 64 times 4/3 pi x cubed. But 4/3 pi x cubed is just v, so we can rewrite this expression as 64v. So when you quadruple the radius, the volume is multiplied by 64. For B, we want to determine what happens to the surface area S and the volume V when we multiply the radius by n. When we multiply the radius x by n, we get nx. We then substitute nx into the surface area formula. The resulting expression is 4 pi times the square of nx. We can rewrite this expression as n squared times 4 pi x squared. But that's just n squared times s. So when you multiply the radius by n, the surface area S is multiplied by n squared. To determine what happens to the volume, we substitute nx for r in the volume formula. We get 4/3 pi times the cube of nx. When we cube nx, we get n cubed times x cubed. So this expression can be written as n cubed times the quantity 4/3 pi x cubed. But that's just n cubed times v. So when you multiply the radius by n, the volume v is multiplied by n cubed. For part C, we want to determine what happens when we divide the radius by 3. When we divide the radius x by 3, we get x over 3. So we substitute x over 3 for r in the surface area formula. We get the expression 4 pi times the square of x over 3. When we square x over 3, we get x squared over 9. We can rewrite this expression as 4 pi x squared all over 9. But this is just s divided by 9. So when you divide the radius by 3, you divide the surface area S by 9. To determine what happens to the volume V, we substitute x over 3 for r in the volume formula. We get 4/3 pi times the cube of x over 3. When we cube x over 3, we get x cubed over 3 cubed, or x cubed over 27. Now remember, we're trying to determine what happens to v. When we look at v, we see a factor of 4/3, a factor of pi, and a factor of x cubed. So we want to leave 4/3 pi x cubed alone, and notice that all of that is being divided by 27. So we just end up with v over 27. So when you divide the radius by 3, the volume v is divided by 27. For part D, we want to determine what happens when you divide the radius by n. When we divide x by n, we get x over n. To determine what happens to the surface area, we substitute x over n for r in the surface area formula. That gives us 4 pi times the square of x over n. But the square of x over n is x squared over n squared. So this becomes 4 pi x squared divided by n squared. And 4 pi x squared is s, so this becomes s divided by n squared. So when you divide the radius by n, you divide the surface area s by n squared. To determine what happens to the volume, we substitute x over n for r in the volume formula. We get 4/3 pi times the cube of x over n. But the cube of x over n is x cubed over n cubed. So we end up with 4/3 pi x cubed all divided by n cubed. But this is just v over n cubed. So when you divide the radius by n, you divide the volume v by n cubed.